So let's just go over how you work with the special right triangle models. Each time I am faced with a set of problems I'd like to do quickly, I prepare a model. Here's my 45-90 right triangle model. Because I know these two angles are congruent, I know the legs opposite them are congruent. So if x is a value on one leg, x must be a value on the other leg. Please review the video on introducing the special right triangles to see why the ratio between legs and hypotenuse for a right triangle is x radical 2. Proving this to yourself a few times using the Pythagorean theorem and understanding why the square root of 2 exists in every problem will be helpful. But at this point, you should be where you can model the 60-30-90 and the 45-45-90 using your senses of these models, what you know about the half equilateral and how that is the same as the 30-60-90. So whatever y is here on the short leg, and I know this is the short leg because it's across from the 30-degree angle, the smaller angle. Whatever y is on the short leg, it is half of the long leg, and I know that there will be a factor of square root 3 between short leg and long leg, or long leg and short leg. And I can use these models to solve problems. So for example, here, if j is 3, in my 45-45-90 special right triangle, I know that k must also be 3. So for each of these triangles given by the data in the column, I know that j and k will be the same. So I can go ahead and fill in j when I have k and k when I have j. I also know that there will be a factor of the square root of 2 between leg and hypotenuse. So I can go ahead and represent that multiplication in each case. So here's how I'm approaching each of these problems. For the triangle given in column 2, you can create a model where each leg has a value of 1/2, and you know that you're going to multiply leg times square root 2 to get hypotenuse, because that is a very reliable ratio. Pythagorean theorem will get you there, but not as quickly. So my leg length is square root 2. My leg length is 1/2, and I'm multiplying by the ratio that I know must exist, which is square root of 2, and I'm simplifying. And here's my result here. Square root of 2/2. There's no radical in the denominator, so that's legal. If I know the hypotenuse, on the other hand, is 8, but I also know the hypotenuse equals x radical 2, I can solve for x using this equation. X radical 2 divided by radical 2 will isolate my leg length, or x, as long as I also divide the left side of the equation by square root 2. So now x, which represents my missing leg, equals 8 divided by square root 2. But this one poses a problem. I need to multiply by number 1 in such a way that the radical is released from the denominator. So All of these values are equivalent. 8 square root 2 over 2 equals 8 divided by 2, which is 4 square root 2. So my leg lengths here we find by dividing square root 2 out of the hypotenuse. We will do the same thing for this last triangle that has a hypotenuse of square root 6 in H. H equals square root 6. I want to go back to a leg. I do that by dividing by square root 2. I know that that result is square root 6. Sorry, square root 3. Because the square root of 6 divided by the square root of 2 is the same as the square root of the quantity 6 divided by 2. So my leg lengths here are the square root of 3. I'm going to make a little space for the 30, 60, 90 work. So the important ratios here are short leg, half the hypotenuse, long leg, square root 3 times the short leg. P is the short leg. Do you see that it's opposite the small angle 30? So if P is the short leg, I know that the hypotenuse is 10. 2 square root 3 is the short leg. I know the hypotenuse is 4 square root 3. 20 is the hypotenuse. I know the short leg is 10. 6 square root 6 is the hypotenuse. So I know the short leg is 3 square root 6. I know that Q is the longer leg in this diagram. That's short leg multiplied by square root 3. So I can now fill in these missing areas. These are a little trickier. I'm going to write those out. But let's take a look at Q. Longer leg is 3 square root 3. I know that long leg equals short leg times square root 3 in a multiplication structure. So my long leg, in this case given by the variable Q, equals short leg times square root 3. So I have a value for my long leg. It's 3 square root 3. Divide both sides by square root 3 to reveal the value of the short leg. The short leg in this case equals 3, which leads me to the hypotenuse, which is 6. 2 square root 3 is this example. I'm going to make room to multiply short leg by a factor of square root 3 to get my long leg in this triangle. And I have 2 square root 9, which is 2 times 3, which is 6. In the last example, 3 square root 6 multiplied by square root 3 equals 3 square root of 18, which can be simplified as 3 square root 9 times 2, which gives us 3 times 3 times the square root of 2, or 9 square root 2. And we use the exact same analysis for questions 9, or for the next series of 3 questions. So I have a 30, 60, 90. I know that my short leg is different from my long leg by a factor of the square root of 3. we're looking for x, which is the hypotenuse, and I know that's double the short leg, so I have 18 over square root 3. And now I simplify. Square root 3 over square root 3 is 18 square root 3 over square root 9, which is 3. 18 divided by 3 is 6, so my result here is 6 square root 3. And I see a square, so that prompts me that I'm looking for side length of x. Any side will do. 12 divided by square root 2, multiplied by a factor of 1, that will rationalize the denominator. So 12 square root 2 over square root 4 gives me 6 square root 2. And take the time to stop anytime I'm moving too fast and analyze the problem on your own. I have a 4, 8, 30, 60, 90 triangle, short side, long leg, 4 square root 3. I have a 30, 60, 90 with a short side of 9. There's x, a y, which is a long leg in that triangle, so there's 9 square root 3. A q that is double y, 18 square root 3. And a z that is different from y by a factor of square root 3. So 9 times square root 3 times square root 3 is 9 times square root 9. 9 times 3 is 27. In the last exercise, I have an isosceles triangle where each of these angles is 30. So I can break this triangle into a 30, 60, 90. And Z is 10. Q also 10. And I'm looking for one hypotenuse. No, it looks like X is an angle measure, 30 degrees. Now where's Y? Ah, there's Y. Y is the hypotenuse for any one of these 30, 90, 60 triangles, where 5 is the short leg. See how 5 must be here and here if one side equals 10. So if 5 is my short side, 10 is my hypotenuse. Oh, but 5 is my long side in this case, isn't it? So if 5 is my long side, then my short side is 5 divided by square root 3. So this is my short leg. And I know that has a difference between short leg and hypotenuse of square root 3. So 5 times the square root 3 divided by square root 3 is 5 is the wrong ratio. Here's my double. The way this is oriented is bothering me a little bit, so I'm going to reorient it for myself because I like to look at the short side here. So 5 divided by square root 3 is the short side. 5 is this long leg across from the 60. And so I know short leg doubled is the hypotenuse, and I still have to rationalize the denominator. 10 square root 3 over 3